why do students struggle? And the research suggests that good problem solvers go through these steps. They understand first, right? And that means looking at the underlying situation and constructing a general model. And that's really what you were saying, Tom. They need to have some organization to that information. Then they need to plan their solution strategy. Then they solve, and then they check. What students who struggle tend to do is they jump right to solve. They see a bunch of information, they look for keywords, or they look for a plausible response, and then they apply, or they might just apply the logarithms that they just learned in class that day. Okay? So the question that we brought up at Tom Snyder Productions was, how can we help students better perform and become expert problem solvers? And where we turned was the research. We'll provide a white paper for the Go Solve Word Problems program for you. And in the white paper, there's 5 tenets, research tenets, that we applied in creating this program. And the first 2 are, one was to teach students how to recognize mathematical situations. And there's actually a large body of research that has formed about, and it depends, sometimes 6, sometimes 9 typical mathematical situations that you can essentially break all word problems down into, okay? And the second is, we looked at a body of research that says you can help students develop mental models using graphic organizers, okay? And what we did is we actually combined those 2 to come up with 3 operation sets and 3 problem types for each operation set. The first is an addition-subtraction, and when you look at addition-subtraction problems, you can break those down into parts and total, change and comparison, and we're going to see some examples of those. Multiplication, you have equal parts with a remainder, and area and array. And then advanced multiplication and division, we can look at part and total, comparison, and proportion, kind of like that last FCAT item we saw was a proportion problem. Okay? So now, as you approach a word problem, if the students understand that all word problems belong to a type of mathematical situation, the first question they're going to ask when they look at the problem is, which type of situation is this? They're going to then choose the appropriate graphic organizer. Asha Jitendra, and he's quoted in the research paper, has done a large-scale study at, he works out of Lehigh University, and what they have found is 2 conclusions. This is number 1. First of all, results suggested that schema-based instruction using graphic organizers could raise the achievement of learning disabled and at-risk students to the level of their non-disabled peers. So what they did was they had 2 groups. One group of students were learning disabled, and a second group were on regular grade level. They broke the learning disabled into 2 groups, and the group that had the advantage of using graphic organizers and instruction in that area performed at the grade, on par with their peers on grade level. And secondly, the researchers found that students in the schema group were able to generalize the strategy use to a set of novel word problems. So once they were able to develop an understanding of the right graphic organizer for the right situation, they could transfer that skill to new word problems. Okay, the third is to break problem-solving process into clear subtasks. And this is kind of what we talked about too, is that typically students who struggle jump past several steps. This is one area, we're going to go into the software in just a second. This is one area where the computer is a wonderful tool. Students are very accepting of a computer and will actually allow a computer to take them through steps in a way that they find it very hard to do with a teacher or even in a classroom setting. So we'll take a look at that. The fourth tenet here is to use anchored instruction to help visualize a real-life connection to each problem type. Kind of like the example Doc gave, if the student has never baked a cake and you're giving an example using measurement from ingredients on a recipe, it has no meaning. But you could actually provide a short anchored instruction video that shows that, they can visualize it, and they will perform much better. The final tenet is to personalize word problem content to make it more relevant and motivating. Actually, Doc's got, he always has these examples from the research. One example was done with students, I think, in second grade. And they were asked the same basic word problem 2 different ways. The first time they were at, or the problem was, there are 5 birds and 3 worms. How many birds and worms are there, right? And, or no, how many more birds are there than worms? And the students did okay on that test. The next time they were posed with this. There are 5 robins and 3 worms. How many birds didn't get a worm? And they did much better because they actually connected to the content. They were kind of concerned about these hungry robins that might be flying around out there. So whatever you can do to personalize that information.